Hi, everyone. It's really great to be back here in person. I'm Shant. I'm a software engineer working on Databricks SQL, and later on I'll be joined by Miranda Luna, who's a staff product manager working on Databricks SQL. So, what has happened in the 3 years since Databricks announced the Lakehouse? Petabytes of locked-in data all alone in the data warehouse were set free to be shared and interacted with in the Lakehouse. Millions of business questions hopelessly unanswered in the data warehouse were brought to the Lakehouse, where machine learning models found the answers. So, it should be no surprise to anyone here that the Lakehouse is great for open access to data and sharing, and of course, integrating predictive analytics. But as Ali pointed out earlier, Lakehouses are great at data warehousing workloads as well. So, how is it that we got the value of the Lakehouse to surpass that of the data warehouse? Databricks SQL. This is our SQL warehouse offering on top of the Lakehouse, where we've been focusing on connecting to your data stack, bringing together the best of data lakes and data warehouses, and obsessing over value with performance. So let's talk a little bit of how we connect your data stack. With Databricks SQL, we wanted a first-class SQL experience that you can use for ingestion, transformation, and consuming your data with any tool out there. For data ingestion, we work great with Fivetran to bring in data wherever it lives. This can be Google, Marketo, Salesforce data, or just files sitting in object storage. You heard Tristan just talk about analytics engineering, and we've been working really hard to make sure that dbt integrates amazingly well with Databricks SQL so you can run your dbt projects and pipelines. And of course, data consumption. Because what good is data that you're just loading and transforming if there's no way to get it into the user's hands? So we've gone and worked with all of these BI vendors to make sure they're all Lakehouse certified. But data is critical, and sometimes just looking at a chart isn't enough. You need to integrate the data into your business and applications. So today, I'm very excited to announce Connect from Anywhere. This is our initiative to make it simpler to connect and bring the data in the Lakehouse into your custom applications. This will be a SQL REST API in preview, open source Go, Python, and Node.js clients so that you can connect this data with the applications or languages that you love the most. Let's talk about how we brought together data warehousing and data lakes. So, Databricks had always been wonderful at letting you put Python and SQL together for your machine learning models. But from SQL directly, the times where you want the flexibility of Python. And so with Python user-defined functions, we're now in preview bringing that functionality to all of the SQL users so they can take the power of Python and bring it into their SQL environments. You can sign up for the preview at this link. Query federation, right? The Lakehouse is home to all of your data sources no matter where they live. And now that's true more than ever with the introduction of query federation in Databricks SQL. You can connect to data sources directly, join them with other data sources, join them with the data in the Lakehouse. All of this is automatic and transparent, and our optimizer will make sure it's efficient execution. Materialized views. These are essential for accelerating common query patterns. And these aren't your grandmother's materialized views, mind you. They're powered by Delta Live tables using the underlying streaming architecture that Karthik explained earlier to make sure your data is always fresh and up to date. Data modeling with constraints. Now you can have informational primary and foreign key constraints to define the relationships between your data. You'll have identity columns that are automatically generated for you. And very importantly, enforced check constraints so that you don't ever have to worry about data quality or data correctness issues, again, when working with your data. So let's talk about performance. The journey to Photon. You see, all of this that we're talking about is in the cloud. And in the cloud, time is money. The faster something runs, the more optimized it is, that's savings. And with Photon, it's our next generation query execution engine. It's MPP execution written in native code, leveraging vectorized CPU primitives, which is just a fancy way of saying it's really fast. In the chart here, you can see with every release of the DBR runtime since 1.0, we got faster and faster in the early days, but eventually it just became hard to get faster, and we knew that we needed something new to get to that next level of performance, and that was Photon. Since we've introduced it, it's processed exabytes of data and billions of queries. Our customers have seen 3 to 8x interactive workload performance improvements. They've run ETL jobs at 1/5 the cost, and on average, a total cost of ownership savings of 30%, and in some cases, up to 80%. And we talked about SIGMOD earlier, the conference where we got the Spark Systems Award. We also shared all of the details and inner workings of Photon in a paper a couple weeks ago, and we're really humbled to receive the Best Paper, Industry Paper Award at the conference. Yeah, it was great. So our customers love Photon, and it's winning awards, and I think it's about time, I'm very excited to announce that Photon is now generally available on the entire Databricks platform. Spark-compatible APIs to accelerate all of your workloads. All right, but what else in performance? This chart on the left here, it shows TPCDS at 100 terabytes. TPCDS is an industry standard benchmark for comparing the value of data warehouses. You can see that Databricks SQL, compared to all of the other CDWs out there, has up to a 12x performance improvement. This is huge. You can read more details about it on the link below. But I really, really want to focus on the chart on the right, because this is something where we've shown that Databricks SQL can be amazing for large workloads, large data sets. But this is TPCDS and a variation of that benchmark, which is an official variation, where you can run 32 concurrent streams of users constantly hammering queries against the system. And what you do is you measure the throughput of that. And you can see over the last 2 years, we didn't start great, but it's gotten 3x better, meeting and if not now exceeding all of the other cloud data warehouses. And so let's focus here for a second, because what is it about queries on small data sets that's so important? Well, so query compilation, when you're running a query, one of the things you first have to do is compile a plan of how to run it. So let's look at this simple query over here. Select AB from T, where C between 5 and 23, limit 1,000. Before we run this query, we sort of need to figure out, hey, what's the best way to run it? And in this case, we ran this query on a small data set, and this is kind of what the timeline looks like. You can see the compilation phase has something pretty involved in it called analysis. This is where we check all the column names, references, and types, make sure they're correct and there's valid metadata. There's the optimization phase. This is where we check the transactional semantics, make sure everything's correct, figure out an optimal way of distributing the work across the nodes. But it's very unintuitive. Sometimes just generating this plan took longer than actually executing and processing the bytes. So here you can see it was about 1.8 seconds to compile it and just 300 milliseconds to execute the query. So we've worked a lot on this problem, and very soon we're going to be releasing the next version where we've optimized Delta, reduced some of the redundant operations in this pipeline, and even some of those operations now run directly in Photon, leveraging the power there. And so we got this query to run 2x faster. But that wasn't enough. We didn't want to stop there. We've got another feature we're working on called metadata pipelining, where we get that box about file listing, because it's a lakehouse, an open lakehouse after all. So data can be coming in from any data source at any time, and we always need to check to make sure we're working on valid sets of data. Instead of waiting for the entire file list to get generated, which can take a long time with things like Parquet, with partition tables, lots of files, what we're doing is we're overlapping the execution and compute while we're streaming the file results out. And then in this experimental system with this query, we further reduced the runtime by another 300 milliseconds. So it's very exciting, and that's not all. There are tons more performance features we're working on. We have a long history in obsessing over sort. In 2014, there's this thing called the gray sort challenge, which is measuring which system can sort 100 terabytes the fastest. And we won in that year. And since then, you know, we've been like, okay, we got to come out with a better version of sort, and we're doing that soon. But everyone's like, don't you just need sort for order by? Like, what's the big deal here? And while that's true in a data warehouse, when it comes to the lakehouse, machine learning and streaming workloads rely on sort for a core primitive. So when we went to make it go faster, we also had to make sure we could handle different size keys, variety of data, unstructured systems. So we put a lot of work in here and really excited that this will be in preview soon to accelerate all sort workloads regardless of the use case. We're adding accelerated window functions to make these operations run faster. And when it comes to reading and scanning data, we've added vectorized kernels to process all the open formats quickly and adaptively deal with all the cloud systems. But I just bombarded you guys with features. The Lakehouse is great. It's time to show you why it's so great. And I'd like to welcome Miranda to do a quick demonstration.
Hello, hello. I am very excited to be here today to show you how the Lakehouse is your best data warehouse. And also we can just double check and make sure Shant's not lying to us about any of these new announcements. So today we're going to do three things. We're going to start with some NYC taxi data. It's just data that has some information about trips, how long they were, what the fare amount was, starting, ending zip codes. And we're going to start by doing some classic data warehousing. We're going to look at our favorite BI tools. We're going to make sure that we can explore and visualize the data. But then we're going to transition to some of the new and exciting things that Shant just announced. We're going to look at query federation. We're going to look at some OLTP transactions, and we're going to show how we can actually leverage those in the same query as one against our historical data in the Lakehouse. And then last but certainly not least, we're going to take a look at using our colleagues in data science gradient boosting model right alongside my query of historical data via a Python UDF. So let's go ahead and get started. Awesome. So right here, what you see, we're starting with a stopped serverless SQL warehouse. This serverless SQL warehouse, I went ahead and pre-configured it to have scaling up to 5 different clusters. That'll come up a little bit later. And what we're going to start with here is actually taking a look at this data using this serverless warehouse in Tableau. So let me go ahead and switch over. OK, perfect. I will enter my password. And as this is logging in, let me just hit sign in. What's actually happening under the hood is this is going to go ahead and load up my dashboard that I already had here. And what that's going to let me do is actually start that serverless SQL warehouse under the hood. Should be up and running in seconds. Yep, there we go. And now we've got our data. I'm going to go ahead and do a quick filter just to make sure that we can actually query it live, our data in the Lakehouse. Yep, that went ahead and adjusted. Perfect. And again, I'm using Tableau right now, but let's just take a quick peek because certainly you can use any of your favorite BI tools, whether that is, and we can see it started, whether that is Power BI, whether that is, if I just swap over, Looker, we get to benefit from a couple different color themes here. Certainly also, we have a connector for ThoughtSpot, have a number of customers using that, and Sigma. Now, of course, me doing one user, one dashboard is exciting, but not realistic. So why don't we actually try to scale that up and see if we can support hundreds of concurrent users. I'm going to go ahead and switch over to this notebook, where I'm going to go ahead and pop in 200 concurrent users. What this is going to do is essentially jigger the query that we had in that dashboard before. And that's going to essentially change all the parameters for those 200 users I entered so that we have unique queries, nothing's cached, nothing is speeding up. And we're going to see if we can get those clusters to pop up to what we looked at, the max 5 that we had set on our auto scale. So, yep, nothing too fancy, just a little scale test. So let me switch back over, and we'll go to the monitoring page. We kick that off. We can see we're still at kind of that 1 cluster, normal size, great. Let me kind of flip this timing. All right, great. Now we're up to 5, and we can see that we're running many more queries concurrently. So from here, we can see that we've already scaled to support 200 concurrent users, whether those are in Tableau, Power BI, et cetera. But why don't we actually take a look at some of this data directly into Lakehouse? Databricks SQL provides a built-in SQL workbench where we can actually query this data, visualize it directly without having to go to a BI tool, just so that we can do some quick spot checks. So here I'm going to take a look at some actual fares, all trips under 10 miles from a couple different originating zip codes. Let's do a quick spot check and make that scatter plot again so we can make sure that the data looks exactly how we expect. So we'll flip to scatter. We will quickly go ahead and pick distance. And we'll also do our fair amount. And then just so we get some different colors, let's go ahead and break that out by day of week. Should look pretty similar. Yep, check. So this is great, but I promised I would show you a little bit more about what Shant kind of just announced. So actually, why don't we start by kind of looking at some recent transaction data that's stored in Postgres in a different system. So I'm going to switch over to this other query. So in this query, I've actually already set up an external table that's going to allow me to query a Postgres in an external system. This is just going to be kind of recent OLTP transaction data, but what this is going to allow me to do in a second, and that's just my secrets, it's going to actually allow me to use the data stored in the lakehouse in the same query as data external. So let's just do a quick gut check and make sure we have data in that table, that external Postgres table. And then the next thing we're going to do in that second statement you see here after this finishes is we're going to actually filter the data in the lakehouse based on what we see in that Postgres table. So here I'm going to say, only show me the trips where that meet under the minimum distance from what I've seen recently. And just like that, we're going to have now updated our view of data in the lakehouse based on what we see in our most recent transactions in Postgres. Pretty exciting. All right. And now, again, I want to switch over. We're a data and AI company, right? So we have to do some AI. This is a gradient boosting model that I'm just going to scroll through real quick. One of my colleagues on the data science team built, but I'm going to go ahead and invoke that in a SQL query directly via Python UDF. So you can see here, we're just kind of building a couple data frames. And if I switch back over to the SQL editor, this is something that I, as an analyst, would have not been able to do before, is to leverage that gradient boosting model. So this first statement that I'm highlighting just shows the actual fares, same thing we just looked at, trips under 10 miles. But this down here, you're going to see we're actually using it to predict fares for trips we don't have historical data for. So trips 10 to 12 miles, I'm invoking that Python UDF. All it needs is the pickup date time as a float and the trip distance for me, and I'm going to go ahead and run that. I've also appended a column so we can quickly tell what's actual and predicted, and do a gut check that everything came out as we expected. So let's just take a quick peek. It looks like we have actual and predicted. So we have now been able to generate forecasted fares directly in the SQL workbench based on a Python UDF my colleague wrote. And over here, I just kind of updated our tried and true scatter plot, and you'll see I'm highlighting the predicted fares in red. And those fares are, again, generated by virtue of using that Python UDF and the gradient boosting model. And then here I have my classic view of the scatter plot we did to start. So seamlessly, I was just able to leverage not just my historical data, but also use that to invoke a model that has been written by one of my colleagues, and I can forecast fares for trips that I haven't had historical data for just yet. So hopefully that was a pretty exciting way to see that Shant is actually telling us the truth. We like to do a small gut check on Mr. Shant, but yes, we are so excited about all the announcements today and all the progress in the past year. And thank you for coming along with us on this journey. There are even more exciting things to come. So with that, I will let Shant take a little bit more thunder. Thank you all.
Thanks, Miranda. Oh, wow. So, if you guys noticed, Miranda was able to quickly start up that endpoint, run her queries, and most importantly, when those 200 simulated users came in, that cluster auto-scaled nearly instantly. And that was with Databricks SQL serverless. And so with serverless, your users get instant auto-scaling capability. Your admins don't need to worry about management, pools, reserved instances anymore. They get simple and predictable pricing. And of course, for budget, it's a reduced total cost of ownership. So very excited to announce today the preview of Databricks SQL serverless on AWS. This means every single Databricks SQL user out there on AWS can log in right now and enable serverless and benefit from the amazing features we showed here. And don't worry, everyone on Azure or Google, it's coming very soon to you as well. So this is the lakehouse, where the best data warehouse is always a lakehouse. You can visit this website to get started. Thank you very much, everybody.